Okay, what's up YouTube? Welcome back to my channel. This is RJ the Computer Doctor. In this video, I'm just going to be going over the exact research that I conducted in order for me to earn my doctorates in computer science. But before I get started, it actually took me 9 years to complete my academic journey. I started my bachelor's degree back in 2015. So in the second to last semester for completing my bachelor's degree, I actually took a class on video game design, and I did a really good job in that class. And what ended up happening was that my professor at the time offered me a position to work with him in his laboratory. He saw all the good work that I did in his video game class, so he offered me a job, and this is the time when COVID happened, so I had no choice but to get a position for working from him. And during the last semester while I was working for him, I also did a really good job completing all my tasks. And then he offered me a 2-year research assistantship in order for me to keep working for him, but also have my master's degree paid for. So if you're a student and you're thinking about getting your master's degree and how much money it would cost in order to complete your master's degree, you can actually get a research assistantship, work for one of the professors in your department, and they can pay for your tuition. So you don't even have to pay for anything. And on top of that, you can get paid a stipend for doing the work for them. So this is actually the research that I produced when working for that professor. I started off doing this research in my master's, and then I continued to do it in my PhD. Okay, so let's get to this presentation. So the title of my research is actually called Enhancing Data Exploration Through a Pragmatic Voice Assistant. So what this fancy title is basically saying is talking to Siri or Alexa and asking them questions about data that you have. So then if Siri and Alexa was smart enough and it had some user interface, it would create those visualizations, allowing people to actually talk to their data. So a lot of this research was actually inspired by the Marvel movie Iron Man, and I was just so enamored by the AI system that was behind JARVIS, which stands for just a rather very intelligent system, if you guys didn't know. And the reason why I like this was because talking to computers and giving voice commands was such a futuristic thing that I would want to work on for a very long time, and that's something that I'm really interested in. So this is what inspired much of the research, and I'm not going to play the video because I'm not sure how the copyright and stuff works, but you can go and check out this clip from Iron Man design. So this research is actually grounded in the old linguistic theories of pragmatics. So the whole idea of what pragmatics is that it tries to look beyond the basic syntax and semantics of what words mean. So just to give you guys an example, if I say the turkey is ready to eat, that can mean two different things in two different contexts. So in the first context, the turkey is ready to eat, people might say that during dinner, and in the second context, people might say it on a farm, where an actual turkey, like a pet turkey, is actually ready to eat their food. So in these two scenarios, they both have the same syntax and the same meaning if they're not read in certain contexts. But once you have that context of where those words were said, then you can get the meaning of those words. So this dissertation is trying to dive into how to retrieve that context in order to better understand user intents. So these are all the different ways that you can try to computationalize pragmatics. You have cognitive environment, which is how people find a common ground with each other. Cooperative principles is actually principles that people naturally abide by in order to get to a certain goal of the conversation. So I'm not going to go through each of these components, but if you're interested, then you can look at this book, Pragmatics in Discourse, and read more about it. But what this PhD dissertation talked about is the cognitive environment and how to make AI more proactive in conversations. So let's dive into cognitive environment. So here we have Bob and Alice. They're having a conversation. Bob mentions he has a bad knee, and Alice says she has 2 children. In the middle is a visual abstract representation of what context means and what a cognitive environment means. They can reference things that have already been said previously. So Bob now has the information that Alice has 2 kids. Bob can ask questions about Alice having 2 kids, whereas previously he did not have that information. So now that information exists, there is more context to the words that Bob and Alice are saying. If you were to examine how Siri, Alexa, and Google work, they don't behave as normally as humans do. What they do is that they use something called wake words, words that you would prefix your query with in order for you to talk to them. This makes it easy for software engineers and developers to create these voice assistants in order to help accomplish tasks from the user. And this is easy for people to implement because people can just say those wake words and then say their command right after it. So what my research is trying to answer is, how do computers always listen? And to answer that question, I'm using the scenario of creating visualizations, helping scientists explore data as like the test bed. So what my advisor always said to me is that you can't just do research because you want to do it. There has to be a meaning behind your research. So this is a National Science Foundation funded research, meaning that the government can't just fund cool projects that I think of. Applying it to this space of creating visualizations, helping scientists explore data is a very powerful use case for this kind of research. Okay, so here are my research questions. What are the advantages of always listening voice assistants in a data exploration context? So what is it good for? And what technical challenges are there with developing an always listening tool? So in order for me to answer research question 1, I need to answer research question 2, which is how to create a system in order for me to test and find the advantages of this always listening voice assistant. So in order for me to answer that question, I developed this system called Articulate. And this was an always listening AI. Keep in mind, this was around 4 or 5 years ago, maybe when ChatGPT and language models weren't so popular. Okay, so then I created this interface called Articulate Plus. So this was an AI operated system. This was actually a web application that I developed, and people could talk to this AI figure right here. People could ask it questions about the COVID data set that I uploaded. So this is right here, it's pixelated, but it says COVID data. And this was a time when, as you recall, COVID was actually on the rise. So on the bottom here was something that we would call a sushi belt, where the visualizations that the AI created for the user, it would pop up on this row and it would be continuously scrolling. And if users saw a chart that they were interested in, you could just simply click on it and it would appear on this little workspace above. So this was the internal architecture of how everything worked. I'm not going to get into the details about it, but basically people would ask the AI, can you show me a chart? And through these various methods, it would create certain kinds of visualizations. One where the user explicitly asked for. So if the user said X and Y, this would be the explicit chart that the user asked for. And an implicit chart, the result of this always listening strategy that I developed. So this was taking into account the context of what the user said. So you can see this transcript here is going into this box, which is influencing what kind of chart that the AI generates. And this top portion here was just a little experiment that we wanted to do on what if an AI could spontaneously create charts for the user and how would they react to it. So then once we had that prototype created, we conducted this user study where we invited some participants. We had people interact with the AI in pairs of 2, and we would measure things like what kind of charts that they were creating and what kind of charts they were selecting. So our hypothesis here was, if users were going to select more of the explicit charts, so charts that they explicitly asked for, that would say that our always listening approach by using context wasn't as effective, and vice versa. If people were selecting this implicit chart, then that would mean that the always listening strategy that we implemented was working. So here were the results, and as you can see from this chart here, we see in this pink and green bars that there was actually no statistical significance between the two, meaning that people were selecting just as much of the implicit charts as the explicit charts that were created. So even though there was no statistical significance in either direction, this means that the strategy that we developed was performing just as good as the method of when people were just explicitly asking for it. So the strategy was doing just as good as Siri and Alexa, but it offered more variety of visualizations for the user. But as you can see in the orange and blue bars, there were a lot of implicit charts that were being created. So the AI had a tendency to create more charts for the user, which isn't necessarily a bad thing. It was just showing the people more selections that they could choose. But the bad thing is sometimes it would be overwhelming for the users because there were too many charts being created. Another interesting observation was even though the users were instructed that they didn't have to use wake words because this was an always listening system, they were continuing to use these wake words, hey Artie, because Artie was the name of the system. And this brings up an important research question. So even though we can develop these systems to perform better by using wake words, they might be negatively conditioning people to talk in an unnatural way to computers. So this is a prime example of how people are learning to use a system instead of the system adapting to the users, which is how it should be. Some other technical challenges that I discovered by conducting this study is that people talk in a soft voice, and sometimes the voice recognition system isn't able to pick up on the user's voices. The second thing that I found was people are taking much longer to say their entire command. So this gets into turn taking in pragmatics. So in a regular conversation between two humans, there's always a little pause between when people talk, and that indicates to the other person whether they can take their turn in the conversation or wait until the person stops talking. And the first scenario that I talked about, the AI always takes a turn. So this is actually a problem that I am going to be pursuing for my future research work. So the question is, when is the right time for an AI to actually take their turn? And when is the perfect time for the AI to let the user think and continue taking their turn? So another thing that I found, going back to these three advantages here, was that I found that the AI could actually create useful charts based on the conversation. And these charts were useful on certain commands that the user said. And those commands were sometimes either incomplete, they were inaccurate, or they were indirected to the AI. Meaning incomplete commands where the user didn't have enough time to complete their entire sentence, and then the AI could fill in those blanks for creating the chart that the user actually desired. And there were inaccurate commands. So whenever the user stumbled upon their words, the AI actually generated a chart that the user wanted. So these were charts that were created when the two people, since there were two people in the user study, they were created based on that conversation between two people, and it wasn't directed to the AI. So these three ways were helpful because the AI could always listen to the conversation. Okay, so that was the end of phase one, where I investigated how an AI could always listen to a conversation and what advantages and technical challenges that would have on the system. So then I got into the research of proactivity. When is the right time for an AI to actually take their turn in a conversation? So this study was actually motivated from this research paper by Vocal and colleagues, and they surveyed around 200 people on how they envisioned the perfect voice assistant. And according to their results, they found that a lot of them wanted an AI that could do more suggestions, proactively scheduling their meetings, or taking the lead in parts of the dialogue. So one of the main conclusions from their survey was the perfect assistant is also foresighted and proactive, anticipating possible next actions. So studying this component of proactivity was a sought after feature that people actually wanted. So these were the research questions that were guiding my research. So we're going to start with one. How does one implement a voice assistant that can appropriately behave proactively during a data exploration task? So in other words, how do you implement an assistant that's proactive? And answering this question of what appropriately means. So this is where getting a doctorate degree in philosophy can actually help you identify the meaning of words and how to define things very concretely. So knowing what appropriately means can be different in many different contexts. So there was this paper published that coined this term proactivity dilemma. So in this paper, there were multiple scenarios of how an AI could be proactive, and some of them were better than others. So if I take, for example, this figure here for number 8, where the AI could do fact checking, some people found this very intrusive while others found it very helpful. You can just imagine it for yourself. If there was an AI that was always listening to you and it could proactively tell you the things that you're saying is factually correct or unfactual. And there were also other scenarios where the AI could clarify disagreements. So imagine you are having an argument with your significant other, and then the AI, since it has the historical context of what the people actually said, it could clarify the disagreement by saying, hey, this is actually what this person said, and it could clear up that disagreement. So you can also imagine in this scenario, some of you might think that, hey, this is very useful, but other people might think that, hey, this is very intrusive. So trying to define what appropriately means was a bit difficult. So this is an illustration that shows how challenging it is to define what appropriately means. Right, one person might enter a person's home and they might want a glass of water. So their proactivity threshold for telling the owner of the house to get them a glass of water might be, it's been such a hot day so far, which for some of you might indicate to the owner, hey, can you grab me a glass of water? While other people might ask a more explicit command by saying, I want water. Right. So what I ended up coming to conclusion to, this is something that I could probably do more research on, was that there are certain people with different thresholds according to what they would consider proactive versus non-proactive. So defining what this proactive behavior means is challenging in this case. So what I ended up doing was I just crossed out the word appropriately and moved on to research question 3. So I crossed out that word appropriately, which gave rise to research question 3, which is how does an individual's personality traits affect their preference over a proactive voice assistant? But I still tried to answer research question 1, which is what are all the different opportunities for how an AI could be proactive? So continuing on from that storyboard paper, I actually analyzed the conversations that people had in phase 1, where I studied an always listening AI system, and then I did a classification. So I tried to build a sort of taxonomy of all the different ways how the AI could be proactive. So I came up with discovery, disagreement, preference, criticism, curiosity, and confusion. You can read more about these opportunities in this paper here. But for the purposes of this research, I focused on discovery. So what I define a proactive opportunity for discovery is basically from the taxonomy that I created in phase 1, I used those commands that I collected through that taxonomy. I analyzed all the conversations. I took each one of those utterances. These were the utterances that they said in the study network. So when users were talking to the AI, it could identify when those proactive discovery opportunities occurred. And in those moments, the AI would generate a chart for the users, and I studied its effects. Okay, so that deals with question number 1. So then I answered the rest of the research questions. So number 2 is basically asking what are the advantages and disadvantages of using a proactive voice assistant, which is whether I could find any correlation between an appropriate proactive behavior and a person's personality traits. So to answer those research questions, I designed this system that is very similar to phase 1, but it had an upgraded AI on the back end using a series of large language models, and I implemented a proactive behavior of when an AI could generate charts based on discovery opportunities. And this is the architecture of how everything worked. I'm not going to go into detail about how everything worked, but basically it followed the same process of users ask a question, then I use whisper speech recognition to find out what people said, and I got a history component that keeps track of the context, and I have the refined query. Then I have a neural network that tells me when an AI should generate a chart for the user. Then I have this large language model that is doing a series of extractions and deciding what chart to create, and then I present that chart back to the user. Okay, so then I conducted a evaluation of the system, and I studied how do people actually interact with the AI. It was a within subject study where people were interacting with both a proactive assistant versus a non-proactive assistant. They were giving 30 minutes each. I gave users a personality questionnaire to grab some information to draw out some correlations for research question 3. And then people were exploring climate data for Hawaii. And these were the measures that I took in order to answer those research questions. So those connected to research question 2.1, this is for 2.2, and this was for research question 3. Okay, so these were the results of how people interacted with the proactive versus the non-proactive assistant, and I studied the order at which they interacted with each assistant. I did some switching for which one they interacted with first. The first thing that I wanted to note was people were a lot more verbal with the proactive assistant if they started with it, and that increase in verbal utterances was actually a statistically significant difference, which was very interesting because people were talking more with the proactive assistant if they started with it. And people were also using more keywords, they were talking more about the data set. They also made more discoveries with the proactive assistant because they could generate charts that the users did not ask for. So here are some heat maps that I created. When people are first interacting with the proactive assistant, people were talking more about the actual data set. But when we look at the counterparts, when people were starting with the non-proactive assistant, we actually see some negative correlations. So in this case, the proactive assistant was doing okay, even if they didn't start with it. But then if they started with it, it was really useful. And in this scenario, I wanted to illustrate how talking to the proactive assistant first, that people were much more confident in talking to it because they were creating charts very quickly. So this is just showing you the time it took users to create their first chart. Whereas people that started with a non-proactive first, they actually were very slow to get started. So those were the results for research question 2.1. And just getting to this discussion here, there was an increased user interaction and there were more discoveries overall. So getting on to research question 2.2, I'm gonna just summarize the findings here. And I found the benefits of interacting with this proactive assistant is useful for 3 reasons. So for one, it improved system ability and effectiveness. So people were actually talking to the system more, they were getting more discoveries, they had an increase of creativity of what kinds of questions to ask the AI. There were an enhanced reliability of the conclusions that people had. So I found cases where people were actually talking to the AI assistant and their conclusions were much more robust because the AI could generate charts for the users. This was a special case where people were voicing their discoveries to the AI, and when they voiced their conclusions and their discoveries, the AI actually showed them the chart that had that conclusion. So it reinforced the conclusions that people had, and if people were saying the wrong conclusions, people would look at the chart more deeply in a different format or a different chart type, and then they could re-evaluate their conclusions. And overall, there were more usage of chart types. People were actually using all the different capabilities of the AI system. Okay, so going on to research question 3, I found 2 slightly positive correlations. So people who are more extroverted tended to like the proactive assistant. You can see the reasoning behind that. People who are extroverted, they might want to talk to people who are also extroverted so they can play off each other. And there was also a slightly positive correlation between people who scored higher on the openness, and they tended to like the proactive voice assistant more. People who were higher on the agreeableness personalities were actually talking more, they made more discoveries, and they were talking more about the data set. So one conclusion that you can make out of this was that if you want to find maybe a partner who you want to collaborate with, maybe you would want to find someone who's higher on the scale of agreeableness. Okay, so this limitation was also influenced by the interaction between 2 people talking to the AI. So I couldn't really reliably get any robust conclusions from these results. This could be a future research direction for any one of you who are completing your PhD to explore this further. And these were the results of people interacting with a discovery proactive opportunity. So that further confounds the results, making much more variability, meaning that if you were to create this on other proactive opportunities, it would give you much different results, potentially. Okay, so that's the conclusion of my research, where I developed this working proactive voice assistant that could help people explore visualizations using voice commands. I evaluated this voice assistant through a user study, and I found multiple benefits like increased interaction, better performance, and increased usage of the features of the system. And I found a little bit of evidence to support that personality traits might be a future research direction for continuing this kind of research work. So what I ended up concluding with was this sort of pragmatics direction was a successful research work that shows some supporting evidence that bringing back these old theories in research is computationally possible now because of the technological capabilities that we have today. And personalization might be an interesting research direction that would come out of this research. And I had some thoughts about the trolley problem, but I can't remember them now. Okay, so that's all I have for this video. Thank you to all of you who stuck around to the end. If you haven't already subscribed, you can subscribe to my channel. I put out new videos every Monday. And if you like to see more content like this, I'm surely going to keep continuing this. And I'll see you guys in the next video.